Hello, this is Mr. Agbamu Idonogrene. I'm here to show you how you can solve this particular question on longitude and latitude in WAEC 1988 number 9. It's a theory question. And before I go on in solving this question, I really want to appreciate you guys for watching my video and always trying to understand it. And one of you said I should solve this, and I'm very glad to assist in solving this question. All I want you to do is just to pay attention and to listen to everything I'm going to explain as we solve this question. So this is a practical question and a standard question taken from the West African Senior School Certificate Examination. This is 1998 question number 9, and it's a good one and a full question which every student preparing for this exam, WAEC exam, need to know, because you can't say what will come out in your exam. So just follow this step very well and you see that it's not difficult. And I'm going to solve this question using this software, GeoGebra, and I'm also going to use the Smart Notebook software, where I'm going to show you how you are going to present your work on a paper. You know, you are not submitting your computer in exam hall. You need to sketch this diagram of the longitude and latitude before you can solve. Then after solving, you can submit your paper. So I will show you everything, but why I want to use GeoGebra to explain it better, I want you to see it real, so that when you are practicing, you can really get the picture of what we are doing. Don't just memorize things and you go like that. It's good you understand what you're actually doing. Okay, let's start with the question. Let me read through so that you understand it. As I read every line, I will interpret it in the diagram. So this question starts with two towns, K and Q, both on parallel of latitude 46 degree north. So let's start with this first sentence of the question. It says we have two towns, K and Q, and both of them are on parallel of latitude 46 degree north. You know, from our introductory class of this topic, I've already told you that parallel of latitude, they are horizontal line that run from east to west. So let me start by bringing my point. So this is my center point. Let me remove the label. So let's remove the label. So this is my center point. Then from there, I get my sphere. You can see the sphere. So this is the sphere. I just wanted to get it real. That's why I'm using this software to solve it. Then let me get my polar axis. Or before I do that, let me put some points on the top and the bottom here, indicating my north and my south. That is this B, then this and this. So you can see the point here indicating the north pole, and you see this point here indicating the south pole. Then this is the center of the sphere, which is the middle of the sphere now. Then this is just a reference point. This is where I'm going to reference my longitude. So let me put my longitude. Let's get our reference point. So I start with this. So from here down to here, down to here. So this is my reference longitude. You remember from the introductory class, we said longitude are lines that runs from north down to south, and they are great circle. So this is a great circle. You can see it running from north pole down through this point down to south pole. So I'm taking this as my prime meridian, as my reference longitude. So this is 0 degrees. So let me put my line from the center of the sphere down to this point. So this is my reference longitude. You can see it clearly. Alright, and I've already set the radius. If I show you the radius now, let me measure the length. This is 6,400. I've already set it. You can see it there. See the length there. This is 6,400. You can see it. So that is the radius of this point from the middle down to this place. Alright, I want you to get it very well. Let me take this out. I don't need it here. Let me hide it. Alright. Okay, let me hide this label. Okay, so let's get our reference parallel of latitude, which is the equator. Let's get our equator that will pass through the center here. I just want you to follow step by step. You see that there's nothing so special about this topic. Okay, before I do that, let me get my polar axis. I need my polar axis. Okay, this is my polar axis. Okay, so which is this. Yeah, so this is my reference equator now, which is my reference latitude. So this is where we are going to start our measurement from. You can see it. So all of them here, they are 0 degrees. Now the question says 46° north. I get a point, place it somewhere here. Let me remove the label. Get my latitude line, which is this, from the center down. So you can see it now. So this is my latitude. You can start from reference 0 just like that. So let me put my angle so that you can see it very well. So get my point from the center down to this place. You can see it clearly. Then let me measure my angle so that you can get it well. So the angle from here to here, I want the name, the value alone. I don't want the label. Alright, so that is it. So the question says we have 2 points. Let me go back to the question. It says town K and Q both on parallel of latitude 46° north. So we know that if I'm taking this line as my reference line, this is my equator, this line, and this is my prime meridian. That means from this point, you can see the angle. Just watch this angle. So this is how it is. So this is 0 degrees. See it. You can see 0 degrees. So north is upward. So we rise up. See, till we get to 46° north, then we stop there. So I just wanted to see it as a real sphere. That's why I'm showing you this. From 0, we rise up 46° north. So let me come down to 46. So this is 46. Let me try and get to whole number so that our approximation will be okay. Okay. Checking. Let me use my arrow to move it. Very close. Okay, I think I'm moving. Okay, let me move it gradually with the arrow of this mouse. Okay. Okay, so this is 46. I've gotten what I needed now. So this is the first part of the question, and these 2 points K and Q, they are standing on that parallel of latitude 46° north. So we need to locate that line first, and that is what I've located in this place. So I think you understand this. But if you want to do this on paper so that you show your examiner what we are doing, if you want to do this on paper, let me go to my smart notebook. All I need to do is to get my circle. Just get your circle like that. So that is it. You get your circle. Then make sure you get the center of the circle. So this is the center of the circle. Then take it out. Then you get your ruler. Then just draw your reference lines. So you know this is on a plain paper, so I cannot make it look real, like solid. But this is how you represent your work on your paper. You can see what I'm doing. So this is my north. This is my south. Then this is my east. And this is my west. You can get it clearly now. And the question says 46° north. Just come top here, make your arc like this. Sorry, let me make it very neat. Just get your arc on this north. That is it. Then make sure you label. Is very, very important. in this topic, labeling is very important because we are drawing on a plain paper. So you need to tell us what is the value of this. So this is 46 degree north. So you can see it down on paper. So this is what you put down on your paper when you are writing the examination. But I want you to see the solid shape. So this is the solid shape. This is how it's going to look like in real life. So we have located 46 degree north. Now let's locate the 2 points now, the K and Q. So let's go on. We say the longitude of town K is 130 degree west. You can see it, 130 degree towards the west. So what they are telling us here is, so if this is my reference line, so west is towards the left on this side and east on the right side here. So since it's west, we are moving, so I need another point. Let me bring the point out here. So I need a point on my left side, and that point is 130 degrees towards west. Let me remove that label. Okay, I can even change the name. Let me rename it as point K. I think, yes, that is point K. So you can see it, point K. Alright, so I need to get my radius to the center of this axis. So how do I do that? Let me create a point at the center here. We need a point there, and this point is going to be 0, 0. Then it's on the Z axis. Yes, so I've gotten the point. So you can see it here labeled as F, but let me take it out. I don't need the name, don't need the label. Alright, so from here down to here, then from here down to here. So that is that. So you can see it clearly. You can see it clearly. So this is the point K. Now all I need to do now, I need to let me put the angle so that we can get it clearly. So this is the angle from this point, this line to this line. That is what is it giving us here? So we're having 24 here. So the question says it's 130 degrees towards west. So let me take it down. So from 0, you can see it from 0, our reference longitude, you move down to 130. See the way it's going? Let me put the longitude line so that we can see the movement. So this is the longitude line. You can see it. So in real life, this is how it's going to look like. 0 degree, you start from 0. So this is 0, you move 130 degrees towards west. See how point K is moving to 130 degrees. When I get to 130, I'll stop there. So this is 130 degrees. So let me try and make it whole number in that place. Okay, so let me move it gradually. Alright, so this is 130 degrees. So that is it. So this is point K, 130 degrees from the prime meridian. You can see it, and you can see the 130 there. So you see the 46 degree from your reference, 46 degree north. You see how it rise up from here, 46 degree north, then 130 degree west. You can see how it goes. So that is that. Then the next point now, it said point K and Q. So Q is where, and that of town Q is 103 degree towards west. So let me locate that also. So 103 degrees towards west. So I need another point. And this point is called point Q. Let me bring it down. It's called point Q. Let me rename it as point Q. Alright, so this is point Q. Let me put the latitude, the longitude line. So this is the longitude line. I want you to take time and look at what I'm doing. I want you to understand it very well. Okay, let me just change the color of this first one I did so that we can differentiate both angles. Let me change it. Let me use red. I think red is more pronounced. Let me try and darken it a little. Okay, to 20. I think this is okay. Okay, so you can see it. So 130 degrees red. Then let me put this 103 from Q to the center. Okay, so let me put the angle. So I need the angle from this center to this place. So that is this value I have here. Okay, so let me change this and this color. Let me use another color. So let me use okay, let me use something. Okay, let's use this yellow. Let me darken it a little, the opacity. All right. Okay. I think we can see it. You can see the yellow. I don't know if it's clear for us. So this is it. All right. So this is Q. So Q is the. Okay, it's not too bright. Let me change this color. Let me change the color of this. Let me change the color of this. The yellow is not too dark. Okay, let me look for a sharper color so that you can see. Okay, let me use this green. I think this green. Okay, let me use this dark green. This dark green is okay. Let me increase the opacity. Okay, all right. Okay, the green is much better. You can see it. So this is the angle, and it said 103 degrees. So from 0 degrees, you can see it from 0 down to 103. You see how it's covering the red, the 130 degree west. So 103 is covering it gradually. You can see how it's going till we get to 103. I will now stop there. So let's go. We are in 95, 8, 103. We are 102 now. Okay, let me go gradually. Okay, let me move it down a little. Oh. Okay, let me move with my mouse to set it down to 103 whole number. Alright, so we are there now. So you can see it. So Q, this is K, this is Q. I think you can see it clearly. Let me put it from the top view so that you can see it well. So you see one, so you see the first one we did 130. So from 0 down to point K here, this is K, is 130 degrees. Then from 0 down to Q is 103 degrees. So the next thing we need to know now is this angle. Now the angle between K and Q is very, very important, and that will be our starting point. What is the angle between K and Q? So that is the most important part in our calculation. We need to get the angle between K and Q. And if you look at the arc here, so K and Q, there's an arc here. You can see the arc, and the angle between K and Q, we need to know it so that we use our length of an arc formula to calculate the distance from K to Q, or Q to K, which is this point. So let me take it off. So I think you can view it clearly. Very simple. Just follow your question step by step. You don't need to rush. Just take your time, understand your question, and have a good sketch. So on this side, if I want to represent that on this side, I can do like from my north, just draw a line, go down like this, take it down here, make sure you label. So this one is 130, let me call it 130 degrees, 130 degrees towards the west. You must label, very important. Then if I do the next one, which is this, so this is just a paperwork. So if you do this, you must make sure you label. So let me label it toward this side. So this is 103. So this is 103 degrees towards west. Yes, so towards west. And 130 degrees, we call it K. So you must label it. Then this other one, we call it Q. So that is it. So this is K, while the other one is Q. I think we can see it clearly. So this is how you represent it on paper when you are solving in your exam, in WAEC exam. Then the next thing is you need to get the angle between both of them. By getting this sketch like this, you are okay. And the center is going to be somewhere here, but you may not necessarily put it. You can use dotted line to indicate it. So this is, so the angle between K and Q, you can see is this angle here, which is somewhere like this. So this is the angle between K and Q. So we need to get that angle, and it's very easy to calculate it. All you just need to do, this is our reference 0. From 0 to Q is 103. From 0 to K is 1/3. So with that we can get our angle. But let's see what the question wants us to do next. So it's talk of another town. It says a third town P, also on latitude 46 degree north, is on longitude 23 degree east. So there's another town. Let's locate that town, which is town P. It's also standing on this point 46 degree north. It's standing on this latitude, but it's on 23 degree east. So we can locate that also. Let me locate it here. So I've told you this is my reference line. So this is my reference line. So there's another point on my east here, which is 23 degree east. Let me get my point. And that point is called point P. Let me change the name. So that is point, let me rename it, point P. Okay. So that is point P, which is this. So let me get my latitude, my longitude line from north, P down. So that is it. Then we can get our angle line from here down to this place. That is all. We can measure the angle. Angle between 0 to this line. So you can see the angle there, which is this. That is 35 degrees. So but the question says it's 23 degrees. So that is this particular angle here. You can see it. So if I move it to 23, okay, let me go step by step. Let me adjust it with my, so this is 97, 98, 99, 23. So you can get it now. So when you look at it from the top, you see what we are doing. Let me view it from the top. So this 23, let me move it. So this is 23. So this is our reference 0. This is our 0 line. From 0 to east is 23. That is point P. You can see the point P here. That is point P. Then 0 to west, Q, which is 103. Then 0 to K, which is 130 degrees. So this is the solid shape I want you to see. By doing this now, all information is known. Every length they want us to find. If I click on the length, I will get my result. But I cannot do that using this software. Let's go and solve it on our paper. So on paper, I'll come down here to indicate the point P. I'll move like this down to my south point. Make sure you label it. And this is point P where they meet. Because they say P is also on this latitude. You can see the 3 points P, Q, and K. They are on this latitude 46 degree north. And this is 23 degrees. So this is 23 degrees to the east. Yes. So that is it. With this, the sketch is okay and complete. You can take this if you want to view it. You can put this if you wish. But by drawing this, just make your sketch neat. Use your compass ruler. Make your diagram very clean and beautiful. That is all they require from you. You know, I'm using freehand to do all this sketch. That's why it's not too fine like this. But you can use your compass, use your ruler, make this thing very neat on your paper, on your answer paper when you're answering it in your WAEC question. And with that, you are okay. So this is the sketch for this particular question, and that is all. The next thing is what they want us to calculate. So let's go to our calculations. By doing this, you will know all the angles between each of the points. K to Q, you can get the angles between them. Q to P, you can get the angle between them. All the angles are all set here. All you just need to know, this is your reference 0, 105, 0, 23. You can see that's why you need to label it. You can see 23. So this line is my 0 line. It's my reference line 0. This northeast line on my paper. Then this is my west east line. This is my reference for north and south. So this is all with the diagram. So let's go and complete the calculations now. So that is all. You can see that our diagram is set. The next thing is what to calculate. They say number 1 says calculate the length of the parallel of latitude 46 degree north to nearest 100 kilometer. So you want us to calculate the length of the parallel of latitude. You know what that means? So let me show you. What they are just telling us to do is we are calculating the full length of this circle. So this is the length of the parallel of latitude. So this is the full length of the parallel of latitude. And when you are calculating length of parallel of latitude, you are also using the formula of length of a circle. So this is length of a circle. So 2 pi r is the formula we are going to use. Then the radius is very important. How do we get our radius? You will get that. I will explain that in our calculation. But I will not. If I just click it here, you will see our radius will appear. But I'll calculate it first before clicking it here, so that you get it. The radius is from this point to the center. So this is the radius of that parallel of latitude. So you say calculate the length of the parallel of latitude 46 degree north to the nearest 100 kilometer. So let's start with that. So if I get my text, okay. So let's get number 1. So length of parallel of latitude. So let's start with that, which is length of a circle, that is 2 pi r. So the length of parallel of latitude is, so let me use L. Let me represent it as L. So L is equals to, that is 2 pi. So 2 pi r. So this is the formula we are using. So the main thing we need to know now is the radius. If you look at this question, radius is given as 6004. So this is the radius of the sphere from the center of the sphere. But this small r is radius of parallel of latitude. And we have a formula for it. And it's r is equals to the capital R, radius of Earth, times, we multiply it by cos alpha. Cos alpha, and what is alpha? Alpha is the latitude on which it's standing, which is 46 degree north. So alpha now, alpha is equals to 6. That is the 46 degree now, 46 degrees. So that is alpha. Alpha is always the latitude on which the point are standing on, and that is 46 degrees. Then capital R is already given. So with this, we can calculate our small r, so that we'll put it here and get our length of parallel of latitude, and that is all. So therefore, L is now going to be equals to 2 times 6. Okay, 2 pi. So pi is given at 3.142 times, then cos. This is cos 46 degrees. Cos 46 degrees. So if you solve this, you will get what? So you can use your calculator. Let me just use my calculator here and do that. So let me use my calculator and complete that. Let's see. Oh, I need my trig. Alright, so I get my 2 times 3.142 times cos 46 degrees. So that is equals to what? So you can see it there. Okay, it's like I did not do one thing. R, we said capital R, I forgot to put it here, sorry. That is time 2 pi r, and r is capital R, which is 6,400. Alright, so I need this one also to complete my work. So L now be equals to, so let me adjust that. So let me edit that. So I need it here also, that is times 6,400. Alright, so this our radius 27,900 and okay, let me just 27,937.49. Okay, 27,900, get it, 937.499, 37.49, and we are in, the unit is kilometer, so we put it there, km, and the question says to nearest 100 kilometer. See it. So if I approximate to nearest 100 kilometer, so I'm going to have my L, no, 100 kilometers, this is unit times 100, so we approximate this down, so we are adding 1 to this, which is 28,000 kilometer. 28,000 kilometer, so that is it. So that is the length of the parallel of latitude. If I come here, I can test it, you will see that is correct. So what we just calculated now is the length of this full circle. This is the parallel of latitude. This is the 46 degrees parallel of latitude. So if I come and measure it, you will see we'll get the same answer. If I say length of this parallel of latitude, you can see it. You see the answer I got? 27,936. You can see it. 27,937, just a small fraction decimal. That's why the question says we should take it to nearest 100, and to nearest 100 you can see it is 28,000. And if I go back here, you can see it. So this is the length, so you can see it there. If I approximate this to nearest 100, see it will still give me 28,000 kilometers. So take note of that. So this is how you do the first calculation. So let me remove this. Alright, then the next calculation the question requires from us to do is let's see, which is the number 2. It said the distance between K and Q to nearest 100 kilometer. So how do we get distance K and Q? That is number 2. So distance K and Q. So this one is very simple, because why do I say simple? We already know the angle between K and Q. It's the angle we need. So all I just need to do is, so distance KQ, so let's do it like this. Distance KQ is going to be equals to, let me go back to the diagram so that you can see it. So this is KQ. So you can see that this is an arc, so we need to calculate the length of this arc. And in order to get the length of this arc, I need to know the angle between the two arcs. Let me show you with the solid shape so that you can see it well. So you can see it. In order to get the distance from this K, you can see K and this Q. You can see it. I need to get the length of this arc. So this is what they say we should calculate. And what is that value? So I need this angle. So this is the angle I'm talking about. And how do I get this angle, which is 130? No, from 0 to K is 130, then 0 to Q is 103. So 130 minus 103 will give me this small angle I need here. So that is that. So, and that, the formula to use is simple and direct, which is theta divided by 360. This is a common length of an arc formula, times 2 pi times 2 pi r. You know, K and Q, they are standing on the small circle. You can see, so the radius of this small circle from here to here, you can see it. So that is the radius we are using, and that is this value. That is the value you are going to get here. Let me see if I can put the value so that you can get it. That is 6,400 times cos 46. So let me just put the value so that you can see it here. Let me calculate it with my calculator here. So 6,400 times cos times cos 46, so which is 4445.81. Just want you to see the value so that you will get it, which is 4445.81 kilometer. Okay, so that is value of the small radius. That is, I'm talking of this radius. So the radius from this point to this place, if I measure it, you will see it. That's what we'll get also, 4,400, and you can see it. You can see it there. See it, 4446.1. You can see just that small approximated value. That's what we are always having. This is 4446.1, and in this calculation here I have 4445.8. So you can just a small fraction approximation. So take note of that. Okay, let me hide this one now. Okay, let's continue with our calculation. Okay, so this is a distance KQ. So let's solve distance KQ now. So now that we get the formula, length of an arc, so we need to get our theta. So theta is going to be equals to, we already know the angle between K and Q, which is 130 minus 103 degrees, and that is going to be equals to what? So let me just do it here. 130 minus 103, so that is 27 degrees. So I have 27 degrees there, so that is settled. Okay, then all we need now, we substitute our small r. You can see this is the value for the small radius. I've already calculated it. I can use it, I'll get the same result. Or I can substitute, like what I did here, 6,400 times cos 46. I can just put it directly into the r, and we settle that. So that is all with distance KQ. So let me solve it direct. Distance KQ is going to be equals to, so theta is 27 now. 27 divided by 360 degrees times 2 times 3.142 times, so we can use this, let me use this value directly, which is 4445.81. So if I do this direct, I will get my answer. So because of time, let me copy this. Okay. Okay, so if I tap my equals to give me my answer directly. Oh, sorry, don't need this. So this is our answer for this question. Let me set it. Okay, so finally distance to KQ now, which is KQ, is going to be equals to 2080.639 kilometer. Then the question says we should take it to where now? It says the distance between KQ correct to nearest 100. So if I approximate it to nearest 100, what am I going to get? That is unit times 100. So I'm going to have 21,000. So KQ is going to be 21,000. So KQ is going to be equals to 2,100, not 21,000 kilometer to nearest 100. So that is the calculation of number 2. That is distance KQ. If I come to our sketch, let me put it so that you can see it here. I'm talking of this distance from K to Q is 2,100 in approximated value, which is 2,080. So let me measure it. You will see that we'll get the same thing here. So all I need to do in my measurement here, let me get a sector. All right. No, let me take a circular arc from this center K to Q. So let me see if I can change the color. Let me use something like red. Okay. Yes. So the KQ, you can see it clearly. Let me put it from top. You can see it. So that is this red point. So let me measure it. You will see we are going to get the same value, which is length of this. Can't you see 2095? And in our calculation we got 208. So this is the value here. You can see 2095, and in our calculation I've told you we always have that small approximated value. That's why we always take it to a nearest kilometer, very important, or to nearest whole number. So if I take it to nearest whole number, I'll still get my 2100, and that is it. You can see it. This software is very, very good for your visualization, especially when you want to understand situations like this. So you can see this distance KQ. You can see the length here. So take note of that. Let me hide it. To be able to hide this one. Alright, so let it go now. Okay, so the last thing the question says we should calculate is the distance between Q and P measured along the parallel of latitude. So you know what that means? It means distance from Q to P along this line. This is the parallel of latitude along this line. They can also tell you to measure it along the north, that is along great circle, so which is going up like this and coming down. They can tell you to measure like that, which is along great circle. So we have that also. I've also done a similar calculation like this. So I did it in 1994 calculation. You will see an example like that in WAEC 1994. There's a question like that. So I've also done it. If you go through my YouTube video, you will see one of the calculation I did on that. But this question says we should calculate on PQP along parallel of latitude. So this is even a simple one. So it's not difficult. All we need to do in this case, let me move all this to one corner, move them to one side. Okay. Alright, let me do it here so there's no need of going to a new page. So number three, so distance along QP is very simple. Let me just put it because of time. So QP is equals to, so it's the same formula we are using, theta over 360. The theta will just be different from this based on the angles between Q and P. So we are using the same formula here, no different from that, which is theta over 360 times 2 pi times 2 pi r. So it's the same formula we are using. The only difference is the theta. This time around, the angle we need is angle between P and Q. So if you look at your sketch, it's clearly stated there. So from 0 to Q is 102. 0 to P is 23. You can see it. If I view it from top, you will see it there. That is 23. Why this is, let's take this out. Why this is 103. So the angle from Q to P now is going to be 103 plus 23, and that is all. So if you just do that now, you have Q is equals to 103 plus 23. That is all, and that is going to be equals to what now? This will not take us time to do the arithmetic. This is going to be 126. I think we are correct. 3 correct, 20 correct. So it's 126, and that is all we are going to put in the formula to complete our calculation, which is 126 divided by 360 degrees times 2 times 3.142, then times, we now conclude by taking your small r, because they are standing on the small circle, which is small r, and that is this value we got here, which is 44445 0.81. So if you solve this down, let me still copy it out because of time. If you solve this out, you're going to get your answer like this. So let me change it to times. Okay. Okay, one thing is missing. Okay. So this is our result now. Let me put it in decimal. So finally, QP is equals to 778.115 kilometer. Then if you approximate, the question says the distance QP along parallel of latitude to the nearest, to this is nearest 10 kilometer we are approximating. So to nearest 10 kilometer, final answer QP is going to be equals to, so 10, this is unit 10, so it's going to be 978. So 9780 kilometer. So this is all this question require from us. So you can see that it's very simple, just because I'm taking my time to explain it using GeoGebra and Smart Notebook. That's why you see it took us a little bit longer. But if you understand it in less than 10 minutes or at most 15 minutes, this question should be true. Should be true with this question in 15 minutes time. It's not a difficult question. Just try to follow what I did in this video. You see that it's not difficult, especially the solid shape I did. I want you to understand it very well. That's why I demonstrated everything in this solid shape, and that is all with the calculation. And if I check now, let me check our result for QP. You see we are going to have this 9778, maybe a small approximated value on this place, just be the dB. We are going to have a close answer here. So if I measure QP, let me create an arc for it also. If I measure from Q, this is Q, down to P, so it's also giving us red. Okay, let me just take the red color because of time. So if I come here and get my length of QP, you can see it, 977.85. so this is our length QP, so 9777.85, which is very close to our result. You see, 9778. I told you we are going to get similar answer because I've already set my GeoGebra to standard scale so that our answer will look alike. So this is all the question requires from Q to P. You can see the length 9777.85, and from our calculation on paper 9778.115. so that is all. So I hope you understand all I did. Hope you enjoyed this video. Just take your time, go through my channel. You'll see most of the calculations I did under latitude and longitude. I've done so many WAEC past questions before. I've solved so many. Just go through them step by step. You see that they are not difficult. The topic is very easy, and if you understand this fundamental principle of what I just did, you see that you are okay and you are good to go. So thank you for listening. Thank you for watching. Till we meet in another interesting video.